Hello, I'm Kevin Gero. I'm Senior Product Marketing Manager for Murata Subsystems. Murata started working on open compute a little while ago, about 7 years ago. I was involved early on in the OCP group with Facebook at the time, Meta now. And as you all know, the mission of open compute is to apply open source concepts to hardware. And honestly, when we started all this and started working on it, people wondered, how the heck you do that with hardware? How do you do that with a power supply? So Murata got involved and basically started working on ORV2 style products, 12 volts, 21-inch shelf, 1 OU, and in 2017 they released that product. It fit into the ORV2 style rack with a 6 across, 18 kilowatt, 15 kilowatt N+1 style power supply. There was an RMU controller to be able to monitor and control the power in that system. So that was utilizing a 3 kilowatt power supply, not too different than what is in ORV3 today, except of course it was 12 volts. And you got the same thing though. You got 6 across into a standard shelf. Very high efficiency, that was the key. You needed this efficiency in order to meet the requirements of the system, to be able to provide power at good efficiency throughout the data center. It was key to this whole operation. When you put it in the rack, you wanted this high efficiency. One of the interesting things is our efficiency curve is very flat because most people were utilizing power all the way up to 90% efficiency, not like when you had servers at N+N and you had a 50% curve and you wanted to be at the peak at that 50%. That's not how it works in the rack because you may be using 20% of the rack, 30%, 80%. You want that efficiency to be good all the way across. We also developed a little different architecture with an ATS in a power supply. So that's at 12 volts and we still have that product. One of the things that happened is a customer came to us and said, hey, I love this ORV3, but you know what, ORV2, excuse me, but I want to put it into a 19-inch rack. And yes, I want those 6 power supplies. So what do? We say, wait a minute, okay, that's not going to work because with 73.5 millimeters across, 6 across, you can't put it into a 19-inch rack. So what we did is we looked at that and said, okay, we make it 2U and we can put it into a 19-inch rack. The other thing that the customer wanted was AC outlets on the back. They had IT gear that they wanted to run off standard AC and they needed the power. So we turned around and we put AC plugs on the back. Obviously they needed to be fused and we made it so that you can bring the different ACs so they could have redundant type power for their switches and that sort of thing. So it's interesting. OCP created a standard, but all of a sudden you have a customer and a need, and Murata did that. So what I'm talking about today is what Murata has done to move OCP forward, at least from our standpoint and our customer standpoint. One of the other things that we found is that if you bring the solid bus bars on the ORV2 style product out the back, you're very limited on how close it has to be to put the nuts and bolts together to make it work. Also, if you have 3 bus bars or you have 1 bus bar, you would have to have different SKUs for power shelves. So what we did is we came up with a very simple idea. We bring the power out on a bus bar that's a horizontal plane, and then we built what we call a link bus bar kit. A link bus bar simply takes that from that bus bar that's horizontal, turns it into a vertical so it can configure with the bus bar in the back of the rack. The nice thing about this is, as you may not know, all racks are not created equal. All bus bars don't have the holes in the same place. It seems like every manufacturer and every customer had holes in a different place. So what we could do is we could build this link bus bar kit and make it fit to anybody's addition without doing a whole new shelf. We simply add a different bus bar kit. We also have developed a 12-volt BBU. It's not ORV2 quote-unquote standard, but it fits to an ORV2 shelf. It's 12 volts. It'll give you 90 seconds of backup. It'll do what you need, actually about 2 minutes of backup. And it's got Murata cells inside it. Each one of the modules in this BBU is 4 kilowatts, so you actually can get 16 kilowatts of backup for that 120 seconds at 12 volts. We keep moving forward. So what happened? All of a sudden, people said, you know what, 12 volts, that voltage drop in that bus bar, that's a big problem. If you start putting more than 8 or 10 kilowatts in that rack, we really can't do it. It doesn't work. So what do? We need to move to 48 volts. Now, of course, when we say 48, we might mean 54, we might be 51, but nonetheless, it makes such a big difference in the voltage drop. It's the only way you can get density into the rack. So we started developing a 54-volt power shelf with an ORV2 style. We started that long before OCP was doing ORV3. So we came out with a product that did just that. It's 6 across, 68 millimeter wide, 3.6 kilowatt each. So you have 18 kilowatts plus 1 in a power shelf. With an ORV2 style, again, you could have a link bus bar kit and make it work. And it fit the needs of everybody. So then what happened is OCP looked at it and said, hey, we need to move 48 volts as well. So this 3.6 kilowatt power supply at 54 volts, we looked at that and said, OCP said we need 51 volts. So we looked at that and said, you know what? If we take this product and redesign it, when I mean redesign it, make it 51 volts, and that's not just changing the output by adjusting firmware or something, because the efficiency is not going to be nice and flat like we want it, and nice and high like we want it. So what we basically did is we took that product and redesigned it. Some of the magnetics had to change. We had to do some tweaking in there on firmware so that we could get that efficiency curve nice and flat at 51 volts, 50.5 volts. So now we have an ORV3 power supply. So then what we did is we took the ORV3 shelf and we just put this power supply in it. So it's not 3 kilowatts a piece, it's 3.6, which is something we already had. But now you get 18 kilowatts, and it's got the ORV3 connection on the back. So it works very well. It fits the ORV3 rack. It meets pretty much the ORV3 specifications. We do not have the BCU that ORV3 and Meta wants, because again, to do the firmware, we're not there yet. So what we did is we utilized our controller. We call it an RMU. But it works. It works in the system, and customers seem to like it. As I said, we simply modified the power supply. I love that when I say that. I'm a marketing guy. The engineers cringe. Simply is not the case. You obviously had to go in and make changes so you can optimize that efficiency and not affect the PFC, not affect the power factor. So anyway, the engineers did that. Now, moving things forward, we've already started talking, and the engineering team is working on a 5 kilowatt version. Unfortunately, we're not going to be able to put that into a 68 millimeter, because when you go to 5 kilowatts, you need that same, try to get 10 to 20 milliseconds of holdup. That means that's a whole lot of capacitor that needs to be done there. And unfortunately, just because I want to move forward doesn't mean that I can make capacitors smaller. That doesn't work. So we need much more space. So we're going to move to 73.5 millimeter wide. That'll still fit 6 across into a 21-inch shelf. What we probably will have to do, though, is if we want to put it into a 19-inch shelf, we'll probably have to go to 2OU or 2U. We're also developing a ORV3 BBU. Murata has our own cells. We're the only power company that does. So we're in the process of developing that ORV3 power BBU to the spec. Each one of the modules would be 3 kilowatts. So you basically have 18 kilowatts with a 4-minute backup. So we're looking at early next year prototypes on that. We're a little bit behind what I know what Meta's doing and OCP's doing, but we'll be there very soon. And the nice thing about this shelf is most of the servers, when they run on ORV3, they don't have a problem down at the 48 volt. They can run at 48 and maybe even down to 42. The high end at 51 or 54 is an issue with some of the servers. So this product can then back up both a 54 volt system, a 51 volt system. It'll work either way. When you get down to 47.5, all of a sudden it turns on and it gives you a regulated 48 volt out. The next thing that we've been working on is we've been talking to customers about immersion cooling. They want more density. They want to be able to put it into a tank and cool it with immersion so they can put 50, 100 kilowatts in a tank. So what we're in the process of developing is a 3U ORV3 style power shelf where we'll utilize the same 3.6 kilowatt power supply today, and it will give us 54 kilowatts at either 54 volts or 50.5 volts. Honestly, at 54 kilowatts, I think we should be using 54 volts. The reason for that is the current is 6.8% less than the bus bar. And when you're talking about 50 kilowatts, that matters. You know, the reason that I think Meta went to 50.5 volts was actually because the efficiency in a 4-to-1 converter in the server versus a 5-to-1 if you're at 54 volts. But when you're talking about running 50 kilowatts, it really does matter, that 6.8% difference in current. You want to reduce the current as low as you can because there is a voltage drop, even though it's much less in a 48/51/54 volt system. There is still a voltage drop. So I've been working with some of the server manufacturers, and we've suggested that they allow for a 54 volt input in this type of immersion product if they can. We can use either 51 or 54, but I think 54 makes more sense when you're starting at these higher currents. So in a few months' time, Submer and Murata will be having a tank with 54 kilowatts and servers to match, and it just get a whole lot of density in a very small space, and that's the name of the game, especially when you're talking immersion. So we're going to be there, and that's where we are today. I know many of the customers have been starting to ask about 150 kilowatts, 300 kilowatts in a rack with cold plates and, you know, immersion and all kinds of different things. So we've started moving forward. We've continued to moving forward, and we'll continue to do so. It's just interesting how we come to these summits, and the World Summit and this regional summit, and we hear new things from new customers all the time. And we take that information and then we start working towards the next level. As I said, we're starting on a 5 kilowatt, 73.5 millimeter power supply. Then we have to have our friends with the connectors figure out how they can get 30 kilowatts out of that small connector. I know they're already working on it. And in the case of this immersion system, I'm already I'm going to use 3 connectors because that's where we are today. But hopefully we'll get better connectors, so better meaning more current capability, more power capability, so I can use fewer connectors in the space. And that'll be the next thing we do. So we'll have to build a version of this that'll handle a 5 kilowatt power supply. Thank you very much.